VLSos here. This is a video lesson on the area model for multiplication. We're going to use this as an opportunity to introduce the difference of squares factoring pattern. We're going to start with a multiplication problem, but this is sophisticated because it's algebraic. We have two terms multiplying two terms. An area model can help us organize and visualize the product of these two factors. An area model puts one factor on one side, in this case x minus 2, and the other factor on another side, in this case x plus 2. And inside the rectangle, I make columns for every factor in the first and rows for every factor in the second. What belongs in each one of these squares is the product of its sides. In this case, what belongs here is the product of x and x, which is x squared. This one is x times negative 2, x times 2, and negative 2 times 2 is negative 4. This area model helps me organize how to find the product. The product is going to be the sum of what I found inside each box. So if I add together these four terms, I get x squared minus 2x plus 2x minus 4. These two terms happen to cancel out. They're like terms. When they combine, they make 0. So I'm left with x squared minus 4. What I started with, I could call factored form. The form of this expression is the product of two factors. What I ended up with and what I changed it into, I could call distributed form. I distributed, that means I multiplied, and what I came up with is a form of the sum of the remaining terms. So the distributed form is the term x squared plus negative 4. These are two different forms of the same expression. These two expressions are equal to each other. They're just organized differently in different form. The factored form x plus 2 times x minus 2 is equivalent and equal to the distributed form x squared minus 4. Now we're going to generalize this. Instead of variables and numbers, we're going to work with the general factored form a plus b times a minus b. I'm going to use an area model to multiply a plus b times a minus b. Two columns, two rows. The product of a and a is a squared. A times b, a times negative b, and b times negative b. So the product of a plus b times a minus b is the sum of the terms inside this model. In this case, a squared plus ab minus ab minus b squared, which I can simplify by canceling out these two terms. They combine to be 0, and this simplifies the rest to a squared minus b squared. Because we started with something general that works for any expressions, a and b. A and b could be numbers, they could be variables, they could be expressions including variables and numbers mixed together. But whatever a and b are, if I start with this type of product, it will always distribute to a squared minus b squared. And in this case, because the result is the difference, we see subtraction, we call that a difference. And because it is the difference of two things that are squared, then we call this type of expression a difference of squares. And in general, if we have a difference of squares, we can convert it to its factored form, which is what we started with in this case, a plus b times a minus b. This is a factoring pattern that has the name difference of squares. And it is very useful. The difference of squares can be used, employed as a strategy, as a way to simplify in many sophisticated algebra problems. You'll use it a lot.